Hi, my name's Stuart Lynch, and this is the 7th video in the Xcode SwiftUI workshop. And in this video, we'll be completing our bucket list application to make sure that we can save and load items that we make changes to and persist the data between sessions. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. You can continue on from where you left off in the last video using the same project, or you can download the completed project from that lesson from the link in the description. Well, we have our app functioning now, and we can add, delete, and update our bucket list items. But when we stop and start the application again, we're back at the same simple array. What we want to accomplish now is to save our list somewhere so that when we start it up again, it can reload and display them. This is called data persistence. And in the iOS world, you can store your data into a database like SQLite that's managed by Core Data, or some other database system like Realm, or in the cloud using Firebase or CloudKit. However, if your needs are light, then you can store your data in a file in a structure format that you can load and populate your models from. So before we do that, though, we're going to move some properties and functionality out of our views into a separate class that in the future we can use in other views should I choose to add to this application. We can create a class and inject that into the environment so that it's observed by any view that chooses to access that class, its properties, and its functions. So we're going to create a new file, a Swift file, and I'm going to call it data store. Inside this file, I'm going to create a new class with the same name. But since the views will need to observe changes on the properties, we must make sure that this class conforms to the ObservableObject protocol. It's in here where we'll be maintaining our array of bucket item and be able to update and delete, etc. from the array. So we can create a variable that we'll call bucket list as we did in our bucket list view. But instead of it being a state property, which is a view-only property wrapper, we make it a published property wrapper. And we'll initialize it initially here as an empty array. Well, when this class gets initialized, we'll want to load the stored items and assign them to our bucket list property. Well, whenever a new instance of a class gets created, an initializer function is run. But there's no requirement to create an initializer for a class if all of the properties of that class have values, like ours does. Well, we only have one, but it's an empty array. But we can create one and then perform an action within the body of the initializer function. So in our case, we want to call a load items function that we're going to have to create. So let's do that. Let's create a function called load items. And in the body for now, let's just simply assign that bucket list sample array, that static array. Well, now that we have that class created, when our application gets initialized, and that's in the file that's decorated with the @main property wrapper, we can create an instance of this new class. So in that file, create an instance of the data store as a state object. So think of the state object as being the equivalent for a class object as to what state is to a view's property. So now that we have that, in the window group where we present the bucket list view, we can use an EnvironmentObject method to inject that object into the environment so that all views that want to have access to it can. Well, bucket list view is one of those views that we want to have access to it. So I'm going to replace the bucket list state property with an environment object. And remember that that object has already been initialized and that sample items have been loaded and assigned to our bucket list in our data store object. So when we create our environment object in the view and specify the type, which in our case is a data store type, it'll check to see if there is an instance of that type of object in the environment, and it'll assign it to the variable that we specify. If it can't find it, your app's going to crash. So you have to make sure that you do your environment injections. Well, the preview is not going to load because it can't present our list unless it too has access to the environment. So we can fix that now simply by injecting a new instance right here in the preview provider. There are 4 other errors being displayed. We can fix the first 3 errors now, which are references to bucket list, which is no longer a property in this view, but we know that it's a property of data store, so we can now have a datastore.bucketList or a binding using $datastore.bucketList. And we're no longer going to need to pass on the argument into our detail view for our navigation destination, because our detail view is going to have access to the environment as well. So we'll remove that right here in the destination. You'll still see an error here because our detail view is still expecting us to inject the bucket list from here, but that'll get resolved shortly. So let's open detail view, and we'll remove that binding to the variable bucket list. But I'm going to replace that with an environment object for our data store, just like we did in our bucket list view. And I can remove as well from the preview the bucket list argument and add in, though, an environment object modifier. I'm going to cut out the action from our update button, except for the dismiss. And I'm going to replace it with a yet-to-be-designed function that I'm going to create in my data store called update. So it's going to have to be called through datastore.update. Well, this function is going to have 3 arguments, because my update needs to know about the bucket item, which is a bucket item type, a note, which is a string, and a completion date, which is a date. So we can pass on to that function the corresponding values from our view. The bucket item that was passed in, our new note, and the completion date. Return now to the data store class, and we can create that data store update function. And as I mentioned, it's got the 3 parameters that we created as arguments in that call in our other view. That's a bucket item, which is a bucket item type, a note, which is a string, and a completion date, it's a date. And then we can simply paste in the cut code that we had used in our button action. Well, we can test this out now by returning to our bucket list view, and we'll see that it's functioning exactly the same. I can delete objects. I can update objects. And I can create new objects. But they're still not being stored. So let's get to that now. Storing information in an iOS app can be done by storing in a database, as I mentioned, like SQLite with a core data wrapper, or in a Realm database using Realm, or even online using CloudKit or Firebase. However, for simple data structures like this, without many demands or records, we can save your list as a structured data file. First, we'll need to have a place to store that data in and a name for that file. And the best place to securely place and store data is in the application's own protected documents directory. And your users can't access that file directly on their phone, only your application can through code. Well, the documents directory can be accessed through a static URL property. So within the data store, we're going to create a new property called file URL that's equal to the URL for the document directory, and we'll append a path using a string that's going to represent our file. And that file is going to be a JSON file, so I'm going to call it bucketlist.json. So the most common format for encoding and storing data is a format called JSON. And it's beyond the scope of this tutorial to go through it in a lot of detail, but the process for encoding and decoding or restoring data to and from JSON is actually quite easy. So to enable this, though, we must first make sure that our object type, which is a bucket item, conforms to the Codable protocol. And since all of our properties are standard Swift properties, all we have to do is specify that it conforms to Codable, because each of those types do. Now we can create a function within our data store called saveList. Inside this function, we're going to try and encode and write the encoded data to our file. Now this may fail if something goes wrong. It shouldn't if we code it properly, but we do need to enclose our attempt in a do catch block. Within the do, we can create a constant property called bucketListData that we can try to encode using a JSON encoders class encode method and pass into it our entire array of codable objects, which is our bucket list. It's that array of bucket item. Now once it's been encoded, we can convert it to a string using the string decoding our bucket list data as a UTF-8 type, so we specify it .self. Well, now that we have it as a string, we can take that string and call the string's write method to write it to that file URL. And we set atomically to true, and we'll use the UTF-8 case for encoding. Now, because we had 2 tries, which means that it could have failed somehow, well, we have to catch that error, and we can execute a fatal error indicating that we couldn't encode and save our list. So our app's going to crash, but the app would be no use if we couldn't encode and save the data anyway. So to get a better understanding of JSON encoding, please review my playlist on that topic. It covers both JSON encoding, like we're doing here, but also decoding, which we'll be covering next. But first, let's update our code so that we can have a save function every time we make a change to an add, update, or delete. So in bucket list view, where we have our action where we add our new item, we can just simply call the datastore.saveList function. Also, when we delete, in that swipe delete, in the onDelete action, we can just call that datastore.saveList. After completing this project and reviewing this video, I realized that I forgot one thing. When we update the item name in this list view, we're not saving it. We need to save the list once more here, and we can do this with an onChange method on the for each loop that watches for changes on the bound item. When it notices a change, we can call the saveList function once more. So this can be called before the list row separator modifier. So we'll use an onChange of item, and that's going to provide us with some sort of a new value, but we don't really need that, so we can just replace that with an underscore in place of that new value. And then once a change has been noticed, we can call the datastore.saveList function. You won't see this in the rest of the code in this video, so make sure you've updated your code to include this onChange modifier. Well, in detail view, we could call that function in the update button action after it calls the datastore's update function, but why not add it to the update function in datastore itself? Now, rethinking this a bit, we may wish to add the creation of new items and the deletion of items to other views in the future. So why don't we refactor the update and delete code that we just fixed up in our bucket list view and move those actions into the data store. So cut out the first 2 lines of the action in the add button in the bucket list view and replace it with a yet to be created function in our data store that we'll call create, which will have one parameter, which will be a new line, a string. Delete the saveList function here too, because we'll add that to our new function. And you'll be left with these 2 lines. So in data store, we'll create that function. Remember, by placing an underscore in front of the parameter name, it'll mean that the call site doesn't have to provide it. Then we can simply paste in that code that we cut out and then remove any references to data store because we're in the data store right now. And once it's been created, we can save the list here. Back in bucket list view, we can replace the delete function by deleting both lines in the onDelete action and replace it with a call to a delete function that we'll have to create in our data store. Well, this will have one argument, which will be an index set, which is a type index set, and we can pass in the index set that we get when we swipe. So back in data store, we'll create that new function and we'll call it delete and provide the index set parameter. Then we can simply paste in the code from our delete function in the bucket list view and then remove both references to the data store here. And once it's been deleted, we can then save the updated list again. Well, to determine and find the saved documents, I'm going to add a line to an onAppear function in our app's entry point that will print out the path to that directory to the console when the app loads. So in that bucket_list app file, the one decorated with app main, after the data store is injected into the environment, I'm going to create an onAppear block. And in the body then we can print the url.documentdirectory.path. So this means that when our app loads, the path will be shown in the console. So let's test and run this now on a simulator. I'm going to run the app and I'm going to add, update, and delete a few bucket list items just to make sure that I perform some updates that's going to force a save list function to be called. You'll notice that there's a lot of output on the console, and most of those are simply false errors about constraints in SwiftUI that I don't understand why they're actually there. Don't worry about those. However, you'll find the path to the documents directory is here. And it'll be /user/URID, library, developer, so on and so forth. What I want you to do is just to select that text, and then you can right click and choose from the menu here, Services, and choose Open. And then when the file dialog appears, you can click on the Run Service button. And this will reveal the documents directory for that application. And you'll see the bucketlist.json file. If you right click on this file and open it with a text edit app or any other text editor, you'll see this JSON string. I want to take a closer look at this JSON string. So I'm just going to copy it, and I'm going to open a web browser and go to this site that's called jsonformatter.org. It just allows me to paste in the copied text on the left-hand side that's not formatted, and then I can click on Format, Beautify, and I'll get a better representation of the JSON object. You may notice that it's an array of objects just like our array of bucket list items, and each item consists of a key value pair with each key representing the property name of our bucket item struct and the values corresponding to the values of our array objects. This is the beauty of JSON Codable. If we run again, however, we're back to the original. We still need to be able to load our JSON, which means we still have to load that saved file when we launch our app. So currently our load items function is loading our sample data. What we need to do is to check to see if a file called bucketlist.json already exists and then decode it and populate our empty array with that we just received. So first let's check to see if the file exists at that path, and we can use the file manager instance's file exists method at the path specified by the file URL.path. If it does, we'll try to get the data from the contents of that file URL. Well, this might fail. So like the save list function, we'll create a do catch block. In the do block, we can let the data be the result of when we try to get the data from the contents of that file URL. If it doesn't fail, we can then assign to our bucket list published property the result when we try to use the JSON decoder's decode method, where we have to specify an array of bucket item dot type from that data. Now, if either of these two functions failed, we can simply call the saveList function, which will create a new file at the URL with our empty array and thus overwrite any corrupted files that might be there. So I'm just leaving a comment here to specify that if the file is corrupt, then we might as well replace the damaged file with a clean one, empty array. So that's why we're calling saveList. If I run once more, we'll see our updated lists items are now loaded. Well, we're almost done. But let's delete all items in the list by doing that swipe delete. And you'll notice that the list is looking pretty stark. It's pretty boring. Well, we can spruce this up a little bit now by adding some assets. So right now our app has no icon, but our totals view does not have the image that we saw in the preview that I showed you at the beginning. So you should have two assets available to you right now. First is an image that's a 1024 by 1024, which is the required size for an app icon. So let's open the assets folder in Xcode, and I'm going to drag that file onto the app icons placeholder in the assets folder. The second item in our assets is that smaller version with rounded corners that's a size of 256 by 256. So I'm just going to drag and drop that into the assets folder, and it's going to create an image asset with the same name. So now back in bucket list view, I can enclose the list and its modifier in an if-else clause that checks to see if the data store's bucket list is not empty. So if we do a if datastore.bucketlist is empty, the code block here will not be the one that we want. We want this only if it's not empty. So we can negate this if clause by putting a exclamation mark in front, which now specifies that if this not data store bucket list is empty, and then in that if case, then our code is good. Well, if it is empty, we'll need an else clause. And it's here where we can create a new text view, and we'll simply present the string, add your first bucket list item. And then we're going to follow this with an image using the asset bucket list. And since this entire view is embedded within a VStack, these are just going to be vertically stacked on top of each other. And let's add a spacer to push it all up to the top. If we refresh our preview then, we'll see that this is how it looks when we've got an empty array. So let's run it once more in the simulator. And when the application launches, you'll see the list is empty because remember we deleted them all the last time and it stored it. But as soon as I create a new item, it shows up in the list and the image and the text view are no longer visible. And if we exit to the home screen, I'll see that my app icon is being displayed for my application. Perfect. Well, that completes the development of this application. For the final application in this series, we'll be querying a web service called an API by providing a postal code or a zip code for a selected country, and in return, we'll receive the location that we will be able to use to plot and display that location on the map.